Hello, 4th grade. Hope you're all doing well. I wanted to give you yet another lesson on simple machines today. And actually today, we're not going to be learning any new simple machines, but I just want to help you learn how to think about simple machines a little bit better. So, as a reminder of our definition, simple machines are devices that help us apply force. So sometimes they help us change the direction of that force, or make it so it's a little more efficient to apply force, like in a lever, where you can lift something heavier than you would normally be able to lift. And the 6 simple machines that we learned were the lever, pulley, inclined plane, wedge, wheel and axle, and screw. And at this point, these all should look familiar to you, and if any of them don't, you can go back and watch the video lesson again. But if they do all look familiar, you can celebrate because now you know all of the 6 main simple machines. And that's a very wonderful thing to do, especially if you want to be an inventor or if you just want to learn how to do things efficiently. Being able to know how to get that mechanical advantage can be a very, very good skill in life, and it can help you solve a lot of problems. And again, here's just a nice little diagram of all the simple machines that we have talked about so far. Now, what I wanted to have you think about today is what to do with this knowledge. Now that we know what the simple machines are, what do we do with that? So, the first thing I want you to know is in most of our simple machine videos, we were talking about only single simple machines at a time. So we talked about a lever, or we talked about a pulley. We didn't talk about like a lever mixed with a pulley or anything. But simple machines don't have to stay separate. You can combine them and make all sorts of fancy contraptions. Just like in those Rube Goldberg machines that we were looking at a couple weeks ago. Being able to combine them lets you do all sorts of fun things, and useful things as well. So being able to combine simple machines lets you make nice contraptions, and you can accomplish just about any task that you want to do using simple machines. So I also want you to be keeping your eye out for simple machines all around you. You're using them every day whether you know it or not, and they're making your life simpler. And I just wanted to go through maybe a quick exercise in helping you think about just how many there are all around you. So I have an example for you. That example is a door. I'm pretty sure all of you have doors at your house, hopefully. And there's actually a lot of simple machines that go into a door that you might not think about. You might think it's just a big plank of wood, and while it is a big plank of wood usually, there's more to it than just that. So I want to just take a moment and look at this and think about the simple machines. And actually, you can even pause the video right now and see how many you can think of. See if you can beat me. If you can, that's great. So, the first one that I think of is a lever. So the entire door really is kind of a lever. Remember, levers, the fulcrum, that is the place where the lever pivots, doesn't have to be in the middle of the beam. It doesn't have to be in the middle of the lever. It can actually be on the very end of the lever as well. And actually, lots of handles and things like that, those levers that you pull up, something like that, they have that form, where the fulcrum is at the very end of the lever, and then you exert the force on the other end, and then the load is somewhere in the middle. And doors work that way. Where the hinges attach the door to the wall, that's the fulcrum. So the whole door moves on those hinges, and you're pushing on the other end. Now, the load is the door itself, that's what you're trying to move. And by pushing on the end that's not attached to the wall, you're able to very efficiently move that door open and closed. And I asked you to do this back when we learned about levers, and you can try it again if you haven't. Try opening a door, like maybe unhinge it, unlatch it, so it can swing freely, and then push the door open, but push near the hinges, so push kind of toward the inside of the door, and feel how much more force it takes to push it the closer you go to where it's attached. And that's because it's lever, and as you go closer to where it's attached, you have a shorter lever arm, meaning you have to apply more force, but for less distance, and that's how that work equals force times distance equation comes into play there. So a lever is the first simple machine you can see in the door. Additionally, depending on the type of doorknob, the doorknob could also be a lever. In this picture, it actually is a lever. It's one of those kind of swinging handle doorknobs. The second one that I think of is a wheel and axle. So the doorknob is a good example of a wheel and axle, especially if it's like a real doorknob that has a big circle on the end, and then it goes into a little kind of puller shaft that goes into the doorknob mechanism then. You're grabbing the big piece of the wheel, and you're turning the wheel, and that turns the axle on the inside as well. If you were to grab just the axle, you'd have to turn with a lot more force because you have a smaller radius, a smaller wheel size there. But by having a nice big knob, that makes it so you can easily turn the doorknob mechanism on the inside, and that will enable you to open the door then. It also lets you pull, gives you a nice handle, but that's not exactly a simple machine there. Additionally, inside the doorknob mechanism, there's a lot of simple machines, but I'm not going to talk about those right now just because we're not as familiar with how a doorknob works, I'm pretty sure. But if you wanted to look inside a doorknob sometime, you could see all the little mechanisms in there that helps it function properly. The next simple machine is a screw. I see this in a door as well. And it doesn't really help with the door's function as much, but it helps hold the door together. So the hinges that attach the door into the wall have to be screwed in, or the doorknob, you actually have to screw that in too. You might notice little screws where somebody has screwed the doorknob into the door. And you can actually take that out and have just a hole there. Yeah, so the screws are used to assemble the door itself, which is pretty cool. And then lastly, the one I thought of, and this isn't actually part of the door, but if you have a door stop that you put to keep a door open, that's actually oftentimes in the form of a wedge. It's kind of a triangle shape that keeps the door from moving. It wedges between the door and the floor, and it keeps the door from being able to open any further. So a door stop is an example of a simple machine as well. So I thought of 4 right here. The other 2 simple machines, let's see, they'd be pulley and inclined plane. I don't think that they really are a part of a door that I know of. I guess you could maybe argue for an inclined plane if you have a door that shuts automatically, like because of gravity, but I'm not going to worry about that right now. Okay, so the next example for you guys to think of, and we're going to do the same sort of thing, is a bicycle. And you know what I'm going to do? I'm actually not going to give you all of the simple machines that I can see in the bicycle. That's going to be your job. I'd like you to take some time and think about a bicycle and see how many of the 6 simple machines you can see in here. And maybe you can even see multiple instances of some of the simple machines. And I'm not going to give you any hints, but just remember here 6 simple machines. You can go backwards in the video if you need to see the list of that again, and see how many of them you can pick out on the bicycle. Because bicycles actually use a lot of them. They're pretty complicated machines, as simple as they look. Okay, so a couple other questions just to get you thinking about this stuff is, can you think of other examples of simple machines? So just like the simple machines where it's not combinations of them. So as you're going throughout your day, I want you to be thinking about, I think that was an inclined plane that I just used, or I think I just used a pulley. And just note how often they actually show up, because they show up quite often. And the other question for you is, can you think of contraptions that utilize multiple simple machines? Because remember, they don't have to stay separate. You can put them together in a door or a bike or a lot of other things. So see if you can think of some contraptions. I bet some of your toys do it as well, that use multiple simple machines. It's neat to see how things work with that. Of course, as well, you can also build your own contraptions, build your own Rube Goldberg machines using simple machines. They're a very useful tool for inventing things. So, that is all that I have for you right now. I hope that you enjoyed our unit on simple machines. They are very useful tools, so make sure you learn how to use them well. Alright, see ya.